This video is just going to cover the intro material for parabolas. So this is going to be the last conic section that we actually cover. And we've dealt with some parabolas before, but we're going to look at a more in-depth look. So a parabola is a set of points such that each point is equidistant to a fixed point called the focus and a line called the directrix. And the only thing that changes for us here compared to what we've written before is that now we've got D1 is equal to D2, which I can't write for some reason. Let's see if we can do this again. Okay, D1 equal to D2. Still can't write right there. Wow, amazing. D2, there we go. Which, like I've discussed before, this first part is just not as, for how we're doing things, it's just not as important. We don't really care about all the background information. We just want to know how to do everything. So you can also get a look over here at pretty much everything given to you like in a graph. And we also will have, or you'll have, the Parabola Overview PDF uploaded. So you don't necessarily have to focus too much on that. All right, so we're going to have two types of parabolas, just like we've had with everything else. So we're going to have a vertical one and a horizontal one. So a vertical one's going to open up and down, or up or down. And then a horizontal one's going to open up on the left or on the right. Now, there are some things that switch here compared to what we've looked at before. So when we looked at hyperbolas, a horizontal hyperbola meant that x led. Now that switches. So now when we have a vertical parabola, x is going to lead our equation. And you'll see what I mean by that as we get into the actual equation. And so then our horizontal parabola, y will lead. So it's kind of counterintuitive, because we've gotten into the habit of making horizontal x lead and vertical x lead. Now we have to flip that for the sake of a parabola. All right, so then we've got a couple different points here, and we can just label everything. So whatever our turning point is for our parabola is our vertex. Okay, so this right here would be our vertex, which I really wish this would write for me. That would be amazing. Vertex. And the point that is within the curve, so that point there, that is our focus. This is just not going good. All right, focus. There we go. And then this point down here is the actual, what we discussed earlier, that D word, the directrix. And then we have a few different things going on here too. We've got this line that intersects and cuts our parabola in half. That is our axis of symmetry. So I'm not going to write that out, but that's our axis of symmetry. And then there's only one thing to really note here as we look at some of the definition stuff. So if we know the distance between the focus and the vertex, that is also P. And then the point from the directrix to the, well, that's like positive P, or plus P, you could say. Plus P. And then the point from the directrix to the vertex is minus P, which you'll look at, that's kind of a formal way to write everything, but we'll look at it in depth and you'll be able to tell the difference between the two because of how we're moving on the X or Y axis. But we'll get into all that. Everything for the horizontal parabola is pretty much the same. Like here would be our directrix, here would be our vertex, and here would be our focus. This line here would be the like line of the directrix, and then everything split down the middle would be the axis of symmetry. So we'll look at some actual definition type stuff, and then we'll get into the actual graphing in the next video. So the focus is always going to lie inside of the, that is supposed to be focus. I have no clue what's going on with my pen. So the focus is always going to lie inside the parabola. That just means if the parabola opens left, it's going to be in that parabola, like on the left. Then the directrix, so the directrix is always going to lie on the outside. So if we have a parabola that opens here, the directrix would be on the outside of that, not inside of the curve. And then the directrix and the axis of symmetry are always perpendicular. So that just means if we look at our two graphs, our directrix, which I hope you have all this written down. So our directrix is our dotted line, which is here, and then the axis of symmetry would be there. So as you can see, those two are perpendicular. And the same thing for a horizontal parabola. Our directrix is here, our axis of symmetry here, they're perpendicular. And then the vertex is the absolute value of p units away from the focus and the directrix, which we'll look at that. That's really, don't let the absolute value part of that confuse you, because we're just saying that sometimes that p may be minus, sometimes it may be plus, but basically it's saying when we're looking at distance, if we just want to keep it from being confusing, they're seeing distance as something that's always positive, but we can actually just use like negative units sometimes, but I'll show you, it'll help you if you can see it as a negative rather than always being positive, because sometimes p is going to be negative, but we'll get to that in a second. I think that'll make more sense when we actually graph these. So don't be too focused on that. Just know that p is, if we're counting to the focus, p is going to be the distance there, and then whatever direction, say that we went plus 5 to reach to go from the vertex to the focus. So say that we were here and to go there was plus 5. That would just mean that to go from that vertex to the directrix, it would be minus 5. So that's what they mean there with that absolute value. So don't get confused on that part, or try not to. All right, so the standard form for these are going to be a little bit weird because we're just not used to seeing it in this format, but it'll make sense once we actually do some problems. So for a vertical parabola, we established that x would lead. So what that means is x will be the variable in your first term. And actually, it's just going to be on the left side of your equation. So our first term will be x minus h squared equal to, now this is where things kind of change. Then we have 4p times y minus k. So that's for a vertical one. So as you can see here, we actually have a equal sign that splits up this equation. And if you have a vertical parabola, x is going to be on the left side, or you'll see x first if you're reading from left to right, and y will be on the right side. So then the only thing that changes from a vertical parabola equation to a horizontal one is that now y is going to lead. So now we'll have y minus k squared equal to 4p times x minus h. And that x minus h and y minus k is still where we get our center from. Or not our center, our vertex, which our vertex is kind of like our center, but that's still where we get our vertex from. Now, just notice that the first term that we have that's on the left side of our equal sign, both of those are squared. And then the term that's on the right side is not squared. So when we have a vertical parabola, we can determine the direction that this parabola opens. It opens up as if p is greater than 0, and it opens down if p is less than 0. And then when we have a horizontal parabola, if p is greater than 0, it opens up right. And if p is less than 0, then it opens up left. So that'll be some important information that we'll refer back to. But for now, just get all of this information down. Then we'll start incorporating it into actual graphing in the next video.